Hey YouTube, it's your boy Zar Charchar, and yes, this is a little bit of a different intro, I know, but I just wanted to, real quick before I start this tutorial, I wanted to say thank you so much for the 100 subscribers, and also for the love and support I received on the Mario Kart Drift tutorial. I'm sorry for not posting any content in like forever, effectively, but the content shall resume because I am on summer break now, which is very, very exciting. And this video is more of a bit of me trying to get back into the groove of things. It's a very simple mechanic, I'm aware. Don't worry, my advanced mechanic tutorials aren't going anywhere anytime soon. In fact, I got a custom engine, how to open up your project in a custom engine, Unreal Engine build tutorial lined up. And I also have a part 2 to my crosshair tutorial. If you really wanted to do an in-world crosshair, just because honestly I haven't really seen any games that do an in-world crosshair, so if you want to have a unique mechanic for that for your game, definitely check the tutorial out. But anyways, enough of me yapping, let's get on with the tutorial. Hey YouTube, it's your boy Zar Charchar, and I'm back here again with another banger of a tutorial for y'all. This time around though, we are going to try something different. We're going to do a lot more of a simpler mechanic. We are going to make a jump pad that can have variable velocity based on where you place it. This is more of a beginner tutorial. I'm going to base, and in this tutorial, I'm going to go through a lot of the Unreal Engine basics. For example, the hierarchy of the engine, and also just some very simple things of simple things about how things work behind the scenes. So if you're a beginner and you stumbled upon my channel for this jump pad tutorial, this video is going to teach you a lot more than just how to make a jump pad. It's also going to help you learn a lot about the engine as well. But anyways, with all of that being said, let's get into the video. Alrighty, so to begin with, we're going to create a new project from the third person template. Now, if you're from other engines, well, guess what? Unreal's templates are actually usable and do show good practice. So when starting out, I highly, highly, highly recommend you use a template and make some quick games or mechanics with them. Just so that, and by doing that, I guarantee you after tutorial number 12, of whatever tutorial you watch on YouTube, you will understand everything will start clicking and you'll be able to start coding mechanics on your own. Very simple. Anyways, let's go through some settings. Highly, highly, highly recommend that you set your quality preset to scalable. If you're trying to create if you're trying to ship a game out to the public, not everyone's going to have a 5090 in their system. So because of that, you should probably use the scalable quality preset. Don't have ray tracing checked on. For the purposes of this tutorial, we won't be using the starter content, but if you are going to be making a project with a lot of they're going to need a lot of level assets, the starter content is definitely a good thing to have, because if you're not an artist, it provides you with some really useful materials to help make your world pop. But anyways, real quick, one of the things you do have to do with these templates is you have to specify if you want it as a blueprint or a C++ project. Blueprints are actually very useful. In fact, if you're making a single player game, blueprints are actually really good for your use case because they are pre-made snippets of code, and you can really iterate very quickly with them compared to trying to code something in C++. And because of that, I know I'm kind of contrarian here when I say this, but I would highly, highly, highly recommend that you use blueprints if you're making a single player game. Now, you don't really need any sort of massive control on the memory because you aren't doing something like, 1000 AI simulations or something. That being said, of course, if you are doing complicated things like, I'm making a real-time strategy game with 1,000 different units on the field, or I'm making a multiplayer game that needs to be very quick on the server, then yes, you should use C++ 100%. But if your use case is like a simple horror game like Five Nights at Freddy's, blueprints are actually extremely useful, and I would say that they're actually going to let you develop faster. But anyways, once you specify your target location, once you specify your name, go ahead and press, and once you set up your settings properly, go ahead and press create, and let's get into it. Alrighty, so now we are in the level. So pretty much in Unreal, as soon as you boot up a project, you load up the specified level that the editor should boot up on. If you want to change that, you can go into edit and then project settings, and then you can change what the standard boot up level is. The same thing applies when you want to change what is the standard boot up level when you package your game and ship it. But anyways, real quick, after you click into the viewport with right click, you can then move around the camera, and then if you use WAS or D, you basically move forward, backwards, left, and right based on your perspective. So if you look down, moving forwards and backwards moves you up and down. If you look horizontally, then it moves you forward backwards using a W and S, if that makes sense. But anyways, real quick, nice quick hotkey. If you press Control Spacebar, you'll open up this beautiful thing called the content browser. And pretty much this is where everything in your project lives, and you can just basically right-click and specify new folders. And if you right-click, you can basically create any sort of asset you want in the editor. But anyways, now that we have that done, we're going to go ahead and start creating our jump pad. So because we made the third-person template, if we go ahead and press play, you'll see that we have a nice character already set up for us that can jump, can move, and yeah, also has some nice IK stuff set up to where basically the leg can prop itself up onto the edge, which is pretty nice. But we want to make a jump pad. So how do we do that? Well, we have to create a blueprint. And a blueprint, as you can expect, is a asset. Now, there's multiple types of blueprints, and real quick, just for your knowledge, because you kind of need, because if you know this, your Unreal journey is going to be a lot simpler. Everything in Unreal Engine inherits from another thing. And what I mean by that is if we go into third person and to our blueprints, basically third person character has a parent class, and third person game mode right here has a parent class that isn't just the game mode. So if I right click and go to create a blueprint class, you'll see we have all of these different classes, and I'll quickly explain them all to you. So an actor is basically anything that exists in the world. So this is an actor, this is an actor, this is an actor, this is an actor, this is an actor. Everything you see in a world is an actor by nature. If you were to go into the content browser and drag out a static mesh, what happens under the hood is Unreal Engine creates a static mesh actor and then assigns the static mesh that you place into the world to that static mesh actor. So anything that exists in the world is classified as an actor in Unreal Engine. A pawn is an actor, but it can receive input from something. So, for example, it can receive input from a player controller, but it can also receive input from an AI controller. And an AI controller is a separate class in Unreal Engine that lets you do some AI shenanigans. A character is a more advanced version of a pawn. It already has some very basic stuff set up for you, such as collision, movement, and all of it is easy to fine-tune. But because it is already pre-set up for you under the hood in C++, using blueprints, there are some restrictions that you do have. For example, characters are humanoid, so you can't create a creature using the character class. Unless, of course, you want to do some weird things with collision and making the default capsule not the normal collision, but I digress. Anyways, that's pretty much the standard chain for the actor inheritance. In terms of player controller, that's basically taking input from the player controller. Game mode base is pretty much just the rules of a level. This is loaded whenever the level is loaded, and this can be used to define objectives, etc. Then the next thing we have is the actor component, and the actor component is, think of it as a script. So in Unreal Engine, because it's 20 years old, it uses a lot of inheritance. But recently, especially if you used Unity, a lot of what you would do in Unity is you create a prefab, and then in that prefab you assign scripts to it. That's basically all an actor component is. It's just a script. A scene component is more akin to a prefab, because a scene component can be assigned to actors, but it also has some physical presence in the world. So now that we've got them, but that's basically all the common classes. If you open up this dropdown, you can further see the hierarchy of Unreal Engine. Everything derives itself from object, and pretty much everything that ever exists on Unreal Engine can be found here. But you can search to kind of refine that. But anyways, now with that long explanation done, how are we going to create the jump pad? So because we don't really need to control the jump pad, we can just simply create an actor class. So let's do that, and then let's type in BP_jump pad. There we go. Double click to open that up. And then now we are brought into the blueprint editor. So when you open up the blueprint editor by default, you'll have this viewport, which basically is what's going to be displayed in the world. Then you'll have the construction script, which is whenever you compile the blueprint, this will run. So pretty much if you want to do any sort of randomness with the blueprint for whatever reason, you should do it in the construction script, because that way, whenever you place this blueprint into the world, each instance will be randomized while you're placing it, compared to being randomized when you start the game, if that makes sense. And then finally in the event graph, this is pretty much where all the functionality exists. If you're not aware of very basic programming like events, long story short, an event fires whenever you call it. So, for example, and there's usually an activation condition. So, for example, event begin play, it fires whenever the actor spawns in. And because of that, whenever it spawns in, it'll then fire the logic, and then whatever logic is connected to it afterwards. Event tick occurs every single time the computer thinks, and because of that, every single time there's a frame, event tick fires. Anyways, now that we gotten that out of the way, let's go ahead and make our jump pad. So first off, we're going to add the physical representation of this into the world. So we're going to press add, and we're going to search for a cube. Click the cube. And then we're simply going to click, once we have the cube, click onto the viewport, and then press R on your keyboard. This is the hotkey for getting a scale to be able to modify the scale, and we're just going to squish this down to here. Then, if you press E, it's the hotkey for rotations, and then if you press W, it is the hotkey for moving the object around, so changing its location. And what we're going to do is we're just going to go ahead and move it down by 1. So there we go. Once we get that done, the next thing we're going to do is, while we still have cube selected, we are going to press add, and we're going to search for box collision. Perfect. And what happened is now the box is attached to the cube. So if we ever move around the cube, the box moves around with it. But what is this box? Well, this box doesn't have a physical representation in the world. Rather, it's a box collision, and its purpose is to be overlapped and interpret collision. At least that's how it's set up by default. You can change it to ignore things. You can also change it to block things and be an invisible barrier. But the main purpose of the box is to act as an invisible collision thing, whether that's for blocking, overlapping, or ignoring. So the next thing we're going to go ahead and do is we're going to press R on our keyboards again. And we're going to go ahead and expand this out a little bit. There we go. So that way we have a little bit more of a jump pad. Great. So now that we have this box ready, the next thing we're going to go ahead and do is we're going to scroll down on this box. And we are going to go to on component begin overlap. Now this event fires whenever an object overlaps with the box. In other words, it goes into this box collision. So here's what we're going to do. So first off, we are going to drag out of other actor. So other actor is the actor that overlapped with the box, not the box itself. That's why it's called other actor. I actually struggled with this for about 3 hours when I was first learning Unreal Engine. I didn't understand why other actor was named other actor, but that's why it's named other actor. Once we drag out of here, we need to have a way to figure out if it's the player or not. And also, we need to figure out a way to actually call a function from the player. Because by default in Unreal, a character class has a function called launch character. And what launch character will do is it'll automatically launch the character in the air, which is perfect for a jump pad. But the question is how do we access that? Now, in Blueprints, you can't just simply say, oh, I want to call a function from character, because there is no way in Blueprints to confirm that, or to just think that it could be character, because it could be the player, because it might be maybe some sort of destructible object that just so happened to overlap with the collision box, and because of that, that would be considered an actor. An actor doesn't have launch character by default, so because of that, we need to be able to refine this other actor node we have into a character node. So how do we do that? The way we do that is we type in cast2 followed by whatever we want to find. Now, in this case, we want to find character, so we're going to type in character. And what this does is this is a very simple node that simply just casts to the character blueprint. So pretty much if the other actor is of type character, then this cast will succeed, and this execution line will be followed. Otherwise, the cast failed execution line will be followed. It's effectively a if statement, or an if-else statement. But if, thanks to the cast, we also, if it is truly a character, we also get a refined node that lets us that can let us do character functionality. So, for example, if I could drag out of here and I type in launch character, boom, I now have a launch character node that I can call. But if I were to drag out of other actor and type in launch character, I can't get it, And if I were to toggle off context sensitive, this is not a valid reference because actor is not a character. And it's, or let me rephrase that. It might not be a character. You don't know that it's a character, and because of that, in blueprints you can't call a function. You can't call this function that's in character because, well, it may not be a character. So that's why we do this cast. And once we do this cast, we can then launch the character. Great. So let's go ahead and set the launch velocity to 600. And once we do that, compile and then press save. And just as a quick little thing to help you save you some time, if you press these 3 lines, on save on compile, press on success only. And that way, if you successfully compile and you press compile, there is no need for you to save the asset. So now that we've done that, let's go back into the world and let's press Control Spacebar for our content browser. On our jump pad, let's drag this out. There we go. Now it's right there. So if we go ahead and press play and we go over this jump pad, we jump. Let's go. Now there is one thing. I don't want all jump pads in the world to have the exact same velocity. For example, maybe a jump pad that is here, just to kind of make the example a little better. Let's say, for example, I have a higher jump up there that I want to reach, right? How do I make it to where this jump pad, I can use the same jump pad actor for this jump, and I can also use the same jump pad actor for that jump? And the answer to that is having an exposed variable. So if we go back into BP underscore jump pad, if we go and press right click on this launch velocity, we can actually split the structure pin. So a vector in Unreal Engine is made up of 3 floats. This is kind of true across multiple engines as well. And anything that's referred to as a structure. A structure is a variable that's made up of individual parts. In this case, a vector is made up of 3 floats. And for every other structure in Unreal Engine, for example, the sweep result, sweep is a structure. If we right click it, we can split the structure pin. Any structure, also, just so you know, any structure can be dragged out of, and then you can type in break, and then I need to make sure you toggle back on context sensitive. If you type in break, you can pretty much get this much more cleaner node that only shows what pins you're actually using, instead of just simply getting the sweep result, splitting the structure pin, and then boom, you have this massive list. But anyways, that's a nice little tidbit. Back on topic, what we're going to do is we're going to create a variable to define a custom launch velocity. So the way we're going to do that is from launch velocity z, we're going to right click and we're going to promote this to a variable. And we're just going to simply call this jump velocity. Once we do that, compile, and then boom, we now have a default value. Now, what we're going to do is inside the level view, if we go into the details panel, we're going to make it to where there will be a variable that's going to be exposed that lets us customize what jump velocity each jump pad has. So if we go back into here, all we have to do is Unreal Engine makes it simple. Just press this eyeball, compile it again, and then if we go back into the details panel, we now see that we have a custom jump velocity for here. So let's make this custom jump velocity 1000. And then let's place another jump pad. And let's make this custom jump velocity to 3000. Play the level. And just like that, we have 2 different ways of jumping up in the air. I just overtuned that, but we don't talk about that. And yeah. So congratulations, you have created a jump pad in Unreal Engine 5. And chances are is you're probably a beginner, so this is probably your first one of your first mechanics, so congratulations on doing that as well. If you found this video at all and in any ways helpful, feel free to drop a like. And if you want to see some more advanced tutorials, because this is rather a break from my normal content, feel free to give me a subscribe. I'm hoping to start dropping advanced tutorials every week or 2, and it would mean the world to me if you did. But anyways, thank you so much for watching, and I hope you have a great day.